Otherwise, I wouldn't see any of the show.
All right, everybody, welcome. We are at the International Builder Show 2022 in Orlando, Florida, and boy, is it a sunny day. Not. It's raining. We're outside, and I am sitting with Michael Woods. Michael, why don't you tell us a little bit about who you are and who Black Buffalo is, and then let's get into this.
You got it. Well, hello, everybody. Thanks for having us on the show, Dave. I'm Michael Woods. I'm the CEO and COO of Black Buffalo 3D Corporation based in New York. We build the largest 3D printers globally, the fastest ones, and the equipment we sell and lease to general contractors and developers. And we also do a lot of work on the material science side to make sure that the output is really great output for the homes.
You know, before we get into this, coming to these shows is super important. And we cannot do it without our sponsors. HB Elements has been supporting us in all of our live shows while we're here, as well as Stream Logistics, Forward Solutions Group. We're going to be at the Combi Lift giving away some swag. You want some Dave Cooper Live swag, you got to come to Combi Lift this afternoon.
Need some of that.
You definitely need some of that for sure. And Howick LTD, amazing people. So, why did you start this? Like, what problem are you trying to solve with 3D printing?
Yeah, there's a couple of different problems that you have. First one is just materials. Right now, the cost of different commodities such as wood or copper or steel, if you can even find it, it's 2 to 3 times the cost it was just 2 or 3 years ago.
Yeah.
Right? Number one is the cost. 2 is the time. It takes too long to construct any kind of project, whether it's a home, it's a building, it's a factory, it's a bridge. We all know the frustration, even in the airports, how long it takes for the airports to be upgraded. And then third is the output, the type of product. Right? We're building homes that are 2 to 3 times stronger than your regular stick build type of home or CMU block, et cetera. So we're doing things faster, less expensively, and we're doing them in a better quality than you can now. And the big thing here is the cost. What is an affordable home?
That's right.
There isn't an affordable home in this country or any other country anymore. And so this is helping to solve that problem so people can actually be proud of where they live and live in a house that they don't have to spend $1,000 a month for utilities as well.
And you come from the New York City area, the metro area, so you know what high cost of living is.
Oh, yes, we do.
And what affordable is.
Yes.
And considering most of the population lives in these high cost areas, it is not affordable. We have a major problem across this country right now.
Yep.
We have millions and millions of people sleeping in tents.
Yeah.
And the average person can't even afford a home today. So let's talk about the process, the machine, and the concrete. First, I want to talk about the concrete because this is what's cool. The average concrete wall, block wall, or poured on site wall is 3,500 PSI.
That's right.
Right? Maybe 4,000, 4,500. If you're using a precast system, you get up to 5,000 PSI. But not you. You guys are up to 7,500 PSI.
Yes, sir.
Which makes it not water porous, it's watertight.
That's right. That's right. Yes, we're our material, of course, is proprietary, so I can't get deep into the ingredients in the material. But when we're printing, the curing process, think of it like fingers, right? You kind of have rows of the material that's coming, but the inside of the fingers, of course, is one complete cured product, right? So that's where you're getting your tensile strength, you're getting your compression there. So we actually do cure at 7,500 minimum PSI. We could even dial that up a little bit if it needed to be stronger.
Sure.
So in many areas of the world, you no longer even need rebar. Right? We're putting some DuraWall, kind of looks like a hanger, right?
That crosses over.
Yeah, and we just lay that every 10 to 12 layers, which makes it even stronger. And then you leave, you're doing a 2-inch outside wall and a 2-inch inside wall, and then you're leaving a hollow core. And that hollow core is also creating a vapor gap.
Okay.
That creates, without insulation, that creates an R25 rating, where code for the US for insulation for almost all buildings is an R19 or an R20. Right? So we're already a quarter better, which brings down your cost of utilities by about 50% a year. So somebody paying $1,000 is now paying $500 for heating and cooling during the year. So yes, the tensile strength, the compression is the top of the market right now. And the other things that need to go with a builder You know, in construction, everything, Dave, is coded, regulated, standardized.
Yeah.
The biggest issue that the 3D industry has had is that the coding and the standardization has not been there. So we really want to help the industry. So what we've been doing over the last year is getting the material coded with ICC, the International Coding Commission, which
Sure.
everybody at this show
knows.
Yeah,
very
they
well.
know them
Yeah,
very
yeah,
well.
they know 'em.
This is the International Coding regulator in 55 countries, everywhere here in the U.S.
Right.
for every code of building any commercial, residential, or industrial structure. So for us, we've been working on a code called the AC 509. The AC 509 is the standard code by ICC for 3D printed walls or structures. It's 3 parts. It does both the flow of the product, it does the structure of the wall, and it does the output of the wall, like you're saying, how much compression and strength you have.
Right, for sure.
That is eminent for us. We've been spending a year. Everything is in from the 2 labs that ICC chose. We, of course, couldn't choose the lab. And all of those results should be back here in February, March latest. So now you're going to have, for the first time, a globally standardized material that anybody, any printers, not just ours,
Right.
anybody can use. And no longer do you have to get that local exemption from the municipality when you're permitting for a job.
Well, you know, and okay, codes have always been kind of the Achilles heel when it comes to innovative products.
Yeah.
Different ways of building. We see it in the offsite space all the time, you know,
Yeah.
modular and panelized and CLT and all. But you made a point about this being the place where a lot of this is discussed.
Yeah.
The NAHB is the leading lobbyist in,
Yep.
you know, number 3 in the country. I don't know if people know that. They're the number third, is that the right way? They're
the
the third
third.
largest lobbying, you know, in Washington. And no matter what somebody's take is on the NHB, we need them, and they are fighting for everything that we're doing here. And that's why it's so important for you to be showcasing this new technology while we're out here.
And they were great. They called us, gave us an invite here. We were actually not planning on attending.
Yeah.
And they said, look, this technology is important to what's going on globally, and it's important to their mission of keeping up with the newest trends and new technology. So they've been great.
So I got a comment here. George Ryman, what's happening, Mr. George? 3D concrete printing is the future of affordable homes. Will it lead to time and material savings?
Absolutely, it will. Time and material. Let's talk about the time that it takes. For a 1,000 square foot home, going up to about 10 feet high with an inside wall, we can print that in roughly 20 hours.
20 hours.
20 hours. Compared to if you're doing that with stick building or you're doing it with CMU block, that would take weeks.
Right.
2 to 3 weeks.
Yeah.
We're doing it in a day. Right? Now, talking about savings. For us to do that same 1,000 square foot, remember we're printing the frame here, right? So that frame itself, that would take about 30 super sacks. Our super sacks, we order them in 2,000
So
pounds
explain
each.
what a super sack is.
Sure, super sack's a great big bag of concrete, dry material that shows up to the job site from your concrete provider, your supply company.
Right.
You throw that into the silo. The silo is the container.
Okay.
And then that container feeds it into your pump. Your pump throws it, mixes it. Just add water and make the nice soft serve concrete ice cream that's going to be coming out of the nozzle. So the pump takes it through the tubes, and then you start printing like you guys see with the printer in the background. So for us to do a 3,000 square foot home, it takes roughly 30 super sacks delivered, $300 per super sack only. That's only $9,000 for that frame. That's it, for 2,000 pounds of mixture.
Wow. So we got cost savings.
Yep.
We got time savings. We have structural strength.
Yep.
Right. You don't need to do any exterior cladding on this if you didn't want to.
Nope,
right?
not if you want to.
But you could if you wanted to.
You could do some stucco on the outside and frame it out.
Right. And obviously, as the technology grows, it becomes even more affordable.
Yes.
And it builds itself.
Yeah.
Like once it gets going, and we'll show you tomorrow.
Yeah.
We got some other B-roll. Unfortunately, it's raining, so we can't be out there. But we're going to show you some B-roll, and we're going to do some best of shows with our friends from the construction channel and get some of that stuff up.
That'd be great.
But walk us through kind of you know, the process. This machine, it's not just, like you said, it's not one thick bead.
Yeah.
It's several, and it goes, and it prints like the outside, and then it comes back around, and that gives you that gap.
That's right.
Right? How do you do a header, a door, a window?
Yep. So, good questions. So when you're doing a window, and you'll see that tomorrow, when you're doing a window, essentially you're telling the printer to gap out an area.
Yeah.
So you're going to have the printer stop excreting, stop printing, and then it'll just flow to the next area, which is already programmed into that window frame size.
Yeah.
So then it'll start printing again on the other side. Now go around like you're saying, and then the next layer do the exact same thing. Pause the print and restart the print, right? And when you're done, all you're putting is a metal header on top, right? And then the printer will go right over the top of that.
Right over top of metal header?
Right on top. And then you just frame out the window or the door, whichever one it may be, as well as for conduits and for plugins and lighting switches. You're telling the printer where to stop, and it'll leave that hole for all your conduits, all your plumbing, everything that needs to come in or go out. Let's say you make a mistake. Oh, forgot about that hole. I should have done that one too. No problem. You have that 2-inch inside-outside wall and that 4-inch gap.
Right.
So all you're doing is you're cutting a hole into that concrete, and it does not change the structural strength.
At all.
Not at all.
And talk to me about how the roof system works here.
Yeah, so the roof system we don't do because that'd be a pretty heavy roof, right, with concrete. So you usually prefabricate the roof. It's all in the design of the home, and then you can leave let's call it little slits in the top, right? And then your girders or your beams can just be tied right into the concrete walls.
Right into the concrete
right
walls.
Into the walls.
So it's kind of like a monolithic pour.
Exactly.
Right
And if you wanted to have a tie come into that core area so it comes down, you tie it all together, you can do that as well.
I think it's amazing. So I'm actually gonna put this back up on the screen here. I want to talk with what we're seeing behind us here. Let me just take one of these banners down so we get a full view.
Mm-hmm.
So this is one day of work, not even.
Not even. This is a small, tiny house sample that we did. We built a small platform for it because, you know, this grade here is just going down in the parking lot. So
would it be possible to zoom in on that a little bit?
Yeah.
You think? Let's see if we can zoom in while we're sitting here.
So if we staged this for the show. So this is roughly 330 some square feet, a cool little affordable house that has a kitchen area, a living room, a bedroom, and a full bath, right? And a closet and other things.
Right.
If we wanted to print this 300 and some odd square foot area, we would roughly do this in about 10 hours.
In about 10 hours.
Not even, right? It would be a little bit less than 10 hours.
Yeah.
For what we're doing is we're staging half of it is up 3 feet high, that half closest to us right now.
Okay.
And then the other half, we're printing 3 hours a day so that we don't complete this too quick.
Sure.
If we printed more, it'd be done.
Right.
So we're doing 3 hours tomorrow.
That's good.
From 12 to 3.
Yep.
And we're doing 3 hours on Thursday from 12 to 3.
Right. And what are we looking at here? Talk to me about this structure. What's the big yellow thing in the middle? How does this all work?
Yeah, so that's so that yellow thing in the middle, that's the nozzle. So that's the piping and everything that goes around and you know delivers a soft serve ice cream around everywhere. The bottom beams are called our y-axis. The vertical one is called the Z, and that middle one with the pump is called the x-axis.
Right.
So the neat thing about our printers is right there in the middle of that pump or of the nozzle, we can actually extend that out. You can buy another rigging, right? So if a contractor comes and says, look, you're only
doing...
It's
an erector set. You just add to it?
It's an erector set, and you just extend it out, or you extend it further along. So you could have rows of homes, right? That you see everywhere here in Florida, which is all CMU block, which is really boring, by the way. The blocks are 8 inches thick.
Hard work.
It's really hard work. You got to have a lot of labor. Who can find labor nowadays, right? So this takes away that inability to find labor. You can CMU block, you know, till the cows come home with a 3D printer, and just keep on going down the line by buying more track.
I love it. And it gets bigger and bigger. So what's the widest span you can put this to? Does it matter?
No, it really doesn't, because the each different extension is only 700 pounds, so it really doesn't put too much weight on it. If you wanted to go, I don't know why you'd go really, really wide, but it could happen. if it was beyond our limit of that Y and Z axis tension, right, then we would build a new Y Z axis combination. If it went too wide.
And that Y and Z is just it's kind of the width and the right.
That's
and the
right.
Tracks on the both sides. So
exactly
when we
right.
Talk about what that is.
It's a train track erector set.
Right.
Exactly right.
All right. So where to go on this? Let's have some questions here. Paul Barretto, can 3D concrete printing be used in renovation projects, or is it only for new homes?
Oh, that's a really good question. So it's ideal for new homes, for sure, but a renovation project, just like any other house, when you're taking off your north side of your house and you want to extend it out to wings, right? Yes, we could just bring the printer in and you take it off and we start building out to the renovation. No problem. Now, I get a lot of questions on that one as well. What if you built the 3D home? Can you renovate that in the future? Absolutely. It's no different than any other home. You're going to cut off that piece of the wall. You're going to demo that out, and then you're going to extend.
You
it's
just
no
run
different.
The tracks to it and then fill in the gap, just like with a regular home. You build new and fill it.
You got it. And if the tracks don't work, if you can't get the printer for whatever reason, there's not enough space between the two houses that you're building. If that doesn't work, then you could have the printer right beside the house. We precast the panels or the walls, and then you just tongue and groove them in. So it doesn't have to be over the foundation. It can be to the side of the foundation, and we actually, in a way, we do it as wall panels.
As wall panels that can come together.
Absolutely. And not just for residential. You can do it, it's even better for industrial, because industrial is almost all tilt up, right? So you have your steel frame inside your distribution center or your warehouse. So you have your steel frame. Everything right now are just precast concrete panels.
You're doing tilt up walls.
The tilt up walls. We would pour on site, real time, and think about the carbon capture benefit here. You no longer have the trucks going back and forth to the factory all the time, so you're saving the environment, and you're printing everything right on site. You no longer have that lowboy truck. But just like when the lowboy truck would show up and all those precast pieces get unloaded by a crane and get installed and clicked into place with that tilt up, you do the same thing there with the 3D printer.
And you know, it's amazing if you ever are out there and you looked at some of the speed footage or the time-lapse footage of a construction site, a traditional construction site, how many times vehicles and trucks coming and going all the time, the disruption to the neighbors, the disruption to the community, the danger of that happening in a community with kids and anywhere else you're building. So this takes away a lot.
It takes all of it away.
Yeah.
Think about the waste. I mean, how frustrating is if anybody has built a home or built a factory or renovated a home, how many times is that dumpster that you can see in that background full once a week? You towed it away, whatever, it's 1,000 yards.
You're taking my
dumpster.
soapbox, man.
We have zero waste. You know how much we do in a day? We do 2 trash cans, 44-gallon trash cans.
Yeah, and that's just for the cement bags.
That's just for the bags. Exactly right. That's all
I would
it is.
imagine that's true. Yeah, and a lot of people don't know that 30%, when you're building something, 30% of what you paid for ends up in the dumpster. Period, on a traditional job site.
Crazy.
That's where offsite concrete printing is really starting to come about. Let's talk about the future here and what you're seeing. You know, offsite has been talked about a lot. Concrete printing's been talked about a lot. Are you seeing real change happening this year and last year more so than any time before?
Totally. I mean, last year was really the much more acceptance than ever before, not just by builders, but by governments. By disaster recovery firms, internationally. Internationally, there's more projects going on than domestically. Right? You've got hundreds of projects going on now. 2022, this is the breakout year for the industry. You're seeing development projects of 100, 200 and more homes happening, not just globally, but here now finally. You're seeing a good amount of companies that are either creating the technology and being the contractor, or companies like us that are just creating the technology and we want to help the contractor build it out. So you're seeing such a great expansion. I think the next phase of this is doing better for the environment. So we've created the AC509 mixture, which still uses Portland as the binding agent. What we want to do next with our mixture is to create a load-bearing hemp concrete. If we can go there, and it's going to take some time. I would imagine a year to a year and a half for us to do it. This took us a year. So if we can in the next year and a half figure out a lime-based binding agent
Sure.
with hemp fibers rather than polypropylene fibers, you can now create almost a net zero product.
Yeah.
Right?
Sure you do. And hemp's making a lot of strides
It really
in this
is.
industry right now. Go ahead and jack the wood up. Go ahead and jack the steel up. You're just opening the doors for other people to come in, and that's what's happening, especially with hemp. And it's not the hemp you smoke, right? As much as, so this stuff isn't going to get smoked. Hemp doesn't burn, nor does concrete. So
That's
there's
right.
there's some real value to that.
Yeah.
Well, I know it sounds weird that hemp doesn't burn, but it doesn't burn. So, but with that said, it's very sustainable. It's like it's a weed, right? It grows
right.
fast. And if you can use that with your mixture, you cut down on the Portland cement a little bit.
Absolutely.
And you just get a little bit greener and more energy efficient or environmentally friendly.
Absolutely. And actually now the neat thing is, we've got that, though we don't need that insulation because we're in R25,
Right.
but if anybody wants to fill that cavity, you can actually throw in now any kind of mixture there. It does not
Right.
need to be load bearing because of
Sure.
the two walls.
Right.
So you could put in non-load bearing hempcrete now.
Non-load bearing hempcrete now. Yeah, I guess you could, right?
Yeah.
How do you, it's just, it's bonding those fibers.
That's all it is.
That's what you have to work through.
Yeah, it's bonding. It's keeping
Hemp's
away
strong.
mildew. Hemp is very strong. It's very strong. And for many of the different items, such as we put in some really not that attractive, but we just played around making a chair
Porch
and a
seats
table
and
and
benches,
just
yeah.
having fun with the printer over the last couple of days. It's not really meant to do those type
Right,
of things,
right.
but you could do that with hempcrete
Yeah.
as well.
I mean, there's so much innovation and technology happening now.
Yeah.
In the 3D printing, I mean, it's here to stay.
It is.
It really does have a place in the market. It really does have a great opportunity to help us with the affordable housing crisis that
Yeah.
we're going through. But it also has the opportunity to help us with government contracts such as military.
Yes.
These things are great. You could put that in the desert and it can print bunkers for troops to stay
Absolutely.
in, to protect them while they're there, or vehicles, right?
Yeah, because the ballistic pressure here,
Yeah.
right? And actually, we've had the State Department, we've had the United Nations, we've had ambassadors, we've had government officials from Central and South America, we've had our government here. They want to find a way, just like you're saying, this all comes in a truck.
Yep.
It all comes with its own ready-made material.
Back of an 18-wheeler and it shows
Yep,
up.
it shows up, and then the other 18-wheeler has all the material.
And how many people to put it together?
4, 5.
All right,
That's
yeah.
it. You got a crane and a forklift.
Right.
You got 4 or 5 guys and gals
perfect.
that are putting it together. Nobody. We put this together in 12 hours.
12 hours.
12 hours. So think about that. Your forward troop deployment.
Right.
You're somewhere in the world, and you're wanting to put up your wall number one. You're printing those wall barriers, right, as quick as you can. You're notching them together in a tongue and groove,
Yeah.
and then inside you're printing up the barracks in hours, not
Right.
days.
Right.
Right.
Yeah,
And think about disaster recovery in the Caribbean. You've got everything just leveled, right? But you still have that foundation.
Not anymore, 7,500 pounds.
Not anymore. Exactly right. Because they can't build it quick enough
There you
after
go.
the storm comes through before the next storm is
Right,
going to hit
right.
next year.
There you go.
So now you bring that machine in and you can build something fast enough for someone to have a home again before the next tornado or the next hurricane.
Well, that's what we say. # build it better. That's
Yes.
what we're all about. We got to start building it better.
Yep.
We're going to go to a couple more comments, and we're going to come to our closing here. All right, Paul Barretto asks, great to hear the process can be applied to home renovations as there's tremendous opportunity with the existing housing supply. So that's more of a comment.
Thank you
there.
very much, Paul.
Jose Martin asks, hey Jose, thank you for joining us today. How are the energy efficiency coefficients? I mean, the coefficient R in walls in ceilings.
Yeah, okay. So the R factor is the coefficient for a rating of insulation.
Yep.
The lower, the less, the higher, the better. Right? So your normal code for an R value in residential
Right.
is a 19 to 20 rating.
That's right.
Right.
Sidewall.
Yep, exactly right.
Yeah.
And if you need more, then you put a insulated panel on the wall, right?
That's
And
right.
increases your R factor. R factor already starts at an R25 with no insulation within it. So you're already 1/4 higher than code.
1/4 higher than code. Build it better. Code is the
Build it
minimum.
better.
Everybody has to understand.
That's right.
It's the minimum code.
That's right.
Doesn't mean it's the best.
It doesn't mean the best.
Not
and
at
if
all.
and if you wanted more, if you're in extreme conditions, heat, cold,
Right.
etc., you can put insulation in our core
Yeah.
and increase it up to a 40, to a 50.
That's right.
I mean, you could go as high as you like.
Yeah, you really, really could.
Yeah.
Listen, we really appreciate the comments and the questions that you're putting out there. So thank you for that, Jose. All right, so I got a question as
Yes, sir.
well. So, what does the future of construction look like for you guys? And what would be the one thing that, you wish people would ask you about this technology? What would be the one thing you would say? If there's one thing that you could tell me on why this is so great, and then we'll wrap it up with some student
Sure.
questions.
That's a good question. I haven't really thought about one question to ask.
Because there's several.
There are several because it's such a new tech and everybody's
yeah.
learning it. But I think the one thing would be, if I'm let's do it two ways, contractor versus buyer.
Right.
If I'm a contractor, the first thing that I want to know, does it really save me money and time, and does it really build a better product?
Right.
Does it do what it claims?
Yep.
Right? Yes, without question, it does everything that we claim. There are some tweaks in it because with concrete, as people that lay concrete all the time, it's a bit of an art to do concrete. That viscosity and that flow of it, you have to get the use of it, right?
Sure,
and you have to work it, and we'll help you with that.
Right.
Now, if I'm a buyer, I would think, is it safe? Because these are pretty heavy walls. What if they fall in on me? Right? What if I'm sleeping one night and it just falls?
Those aren't falling.
No, there's no way. So it is even safer than the homes that you build and buy right now.
Yeah.
It's not just safer, it's also for you. It's less expensive to buy the home. It's less expensive to maintain the home for you as well. So there's so many benefits for both the contractor, the builder, the developer, and for the buyer.
Yeah. And how about student chapters? Students, are you finding a lot of interest from the younger generation in this? And how are you finding that in the labor force for you to hire them and bring them to work?
Absolutely. So labor's so hard to find.
That's right.
The great thing here is that if for anybody that has a 3D printer at home, when you bring it in and you start to understand it, it's really quite simple.
Yeah.
It's the same thing here because we've already developed a simple product for consumers to use. So in the summertime, when we have interns at our factory in New Jersey, our interns are driving this within 2 weeks.
Wow.
Right? So this is a really simple thing to do, but it's also cool.
Right.
I mean, what kid wants to come out of college or trade school and just go digging ditches or laying CMU block as an example? They don't want to do that. That's hard, sweaty, disgusting work. Here, you got a cool piece of technology that you're creating structures that no one else is creating, and you're making people's lives better. And you're doing it sustainably.
Yeah. All at the same time. Who would have thought? Yeah. We can't keep building the way we've been building for over 100 years.
No.
It makes no sense.
It's impossible.
So we're changing up. Well, listen, I really appreciate you
Thank you,
having
Dave.
us by the booth. Unfortunately, it was raining. We are going to be doing some live video. We're going to come by and do some footage, and we'll be posting that as well. We're going to do a best of, and we're going to make you part of our best of.
Oh, thank you.
That we'll do.
Thank you.
That'll go out tomorrow. We got some other live events happening this afternoon, potentially just IRL streaming, walking through. So we'll show you some more great technology. And again, I want to thank HB Elements. Go visit them inside. They're doing exterior trim like nobody else has been doing it. You want to talk about automating factories, these guys are into it, and they love to fish too. I'm looking forward to go fishing. All right, everybody, listen, thank you so much for tuning in. Stay tuned for more stuff. Hit that subscribe and like button so you get dinged. We're going to be going live today, tomorrow, and Thursday at random times showing you what we're talking about, because this kind of great stuff is all over the place.
Thanks so much, Dave.
Michael, thanks so much.
Pleasure's all ours.
Look forward to coming and seeing you out in Pennsylvania as well.
Yep.
And to the team that's over here and everybody else. All right, everybody, take care. We'll talk to you a couple hours. See you now.
See you, buddy.